And I am Walakanya Singh Pichit. We are students from Princess Julapon Sen High School, Pathum Thani, Thailand. Have you ever seen a bald picture like this? Or like this? This is the current environmental problem about water pollution. One of the reasons for this problem is textile dyeing process. After textile dyeing, they have the surplus utilized wastewater that are highly durable and contain lead compounds, which make them difficult to treat. So many organizations choose to release this wastewater into water sources without treatment, especially in a small organization like community enterprise. In our country, we have the Buddhist as a national religion. Rendering, we have the community enterprise that dye monk loaf for monk. For the reason mentioned above, we think if we develop an adsorbent that is low cost and easy to use, may be an alternative to solving these environmental problems. At the beginning, we were interested to use an adsorbent in sport rubber group, but from the primary study, we found that the sport rubber may not have the potential to adsorb as well. Therefore, we searched more information and found that the Tamarind Seed Pulp has some interesting properties. So it is the beginning of our project, a novel form of sport rubber with Tamarind Seed Pulp for dye and lead adsorption in wastewater from monk rope dyeing.
So, we wash the tamarind seeds with water and put it in microwave with 640 watts for 4 minutes. Crack and peel the tamarind seed pulp to get a seed cloth, and then put the tamarind seed cloth in the boiling water for 30 minutes to obtain the insoluble part. Finally, dry and guide them. We began by studying the appropriate amount of tamarind seed pulp into 5 formulas. Formula 0, 3, 6, 9, and 12 pHR. It was found that the dye and lead adsorption capacity increased according to the amount of tamarind seed pulp increased up to 9 pHR, which gave the maximum adsorption capacity from dye and lead adsorption. Then, we wonder what factors affect the adsorption of sport rubber. Therefore, we began by studying the effect of pH value. We study ranking from pH 5 to 9. And the next factor is initial concentration. We study of 200, 400, 600, 800, and 1000 mg per liter. And the last factor is light contact time. It was found that when the pH value increased, the adsorption capacity decreased accordingly, with wet water at pH 5 showing the highest adsorption capacity for dye and lead adsorption respectively. And when the concentration of wastewater increased, the adsorption capacity increased accordingly until 400 mg per liter, giving a maximum capacity for dye and lead adsorption. And from the graph contact time on dye and lead adsorption capacity, find that the adsorption efficiency increased gradually until the 36th hour, but by the 48th hour, it is noticeable that the graph is relatively constant, thus concluding that it is an adsorbing balance point. In addition, we have also compared with the global effluent guidelines, which states that the color of effluent must be appropriate and acceptable, and the lead concentration must less than or equal to 0.15 mg per liter. The effluent after adsorption has a color value of 293 ADMI, and a lead concentration is 0.1504 mg per liter. So, the effluent can be emissions into water source.
And next, we want to learn an adsorption behavior of sport rubber. So we study about kinetic model and adsorption isotope. By use data from the factor method, we show the model that a square value is the most closer to 1. We study kinetic model according to Pasador's first order, Pasador's second order, and interparticular diffusion model. From the result, we found that sport rubber kinetic model according with Pasador's second order, we show that the adsorption process of sport rubber with tamarind seed pulp creates an intermolecular force in between the dye molecules and the sport rubber surface. This process is a rate-determining step. In addition, the adsorption rate is dependent on adsorption capacity, not on concentration of adsorbate. And for the isotherm study, we choose Langmuir isotherm and Fundish isotherm. From the research, we found that spore rubber isotherm accordant with Langmuir isotherm. This means that dye molecules only catch onto the one layer of the spore rubber surface. Based on other information we have studied, our manufactured product can be used as dye and lead adsorbent for mangrove dyeing. In the future, we hope to have a chance to study different colors and other groups of textile dyes. In addition, if our innovation is widely used, it will be necessary to dispose of the used spore rubber in an environmentally friendly way. Therefore, our project team has an idea to use the adsorbed spore rubber as a planting material for marigolds, in order to add color and add value to marigold as well.